Hi everyone, hope you are doing good. Let me quickly add Moin as well. There he goes. Hey Moin, can you hear me? I think he has not joined yet, so let's give it a couple of more seconds. Oh, there he is. Hey Moin.
Hello. Hi, how are you?
Ooh.
I'm doing fine. I think everything should be working now.
Yeah, it seems so. So I actually started recording a second before you join. You probably should have
Yeah,
the prompt from Zoom notifying you.
yeah. It told me. Yeah,
Okay, perfect.
and I also dressed up,
Oh,
dressed up a
awesome.
little bit.
Awesome. Yeah,
Yeah,
yeah, awesome.
to make it more formal, but I'm
Yeah,
not sure how it goes. Yeah.
yeah.
So,
Yeah, let's keep the ball rolling. How's everything?
fine, pretty fine. I'm doing well. Just keeping up with the crazy number of papers and news in AI that's coming out.
Yeah, yeah. We had quite a week, right? I guess it's only some
Um,
days from the last time we spoke, and we usually speak every 2 weeks, but this time I really felt like that, if we want to wait
hmm.
that long, then we are gonna have a lot of papers that we need to just ignore because of the time being. So yeah, we had
Yeah.
very newsful week last week.
Yeah. And mainly, I mean, the most important one I think was the introduction of the DeepSeek paper and model by the
Definitely.
company, which was crazy, and everyone's freaking out
Yeah.
on how they could achieve such a thing. And I'm not sure if it is in your list, but it was one of the items I wanted to, yeah,
It's
talk
on
about in this one.
Yeah, it's on top of my list as well, so I guess we can go through it in the beginning. But before jumping in, so a couple of other things happened as well last week, kind of a news-like updates. One was the investments that Donald Trump announced, a $500 million
Yeah.
investment in AI that, kind of raised controversial reactions among people who are in the field. Some were very happy about that. Some were kind of in doubt about whether or not it's going to be impactful. That was one thing. And the other thing was
Yeah.
the operator model that OpenAI announced, which is equivalent to the cloud
The
com
computer use, yeah, Claude by Claude, yeah,
com-
introduced earlier. But the difference was that Anthropic or Claude actually didn't provide a working feature. It was just a demo, and they introduced the whole feature and launched it appropriately, and which was yeah, kind of like new in this kind of AI applications.
Yeah, I agree. I mean, I personally believe that the cloud family of models, most importantly, the 3.5 new model, the 3.5, what was the name of those, that advanced version of the model that
The
they,
Sonnet, the Haiku,
the Sonnet one.
uh,
The
Son, yeah.
Yeah, the Cloud 3.5 Sonnet has lots of potentials, but and in many different realms, specifically the coding realm, it outruns OpenAI models. But the point is that OpenAI has this kind of very huge investment into deployment and into coming up with end user kind of applications that are very user friendly, can help you in day-to-day jobs. And this is something that, to be honest, they are doing much better than Cloud. And I guess if Cloud could put a little bit more effort into just, making its products more user friendly, more tailored towards the end user, that could be even much better. But still, the competition is going forward, and we as the audience are very excited to also be the users of this competition. So whatever they develop, we can use, and it's interesting, very exciting.
Yeah, definitely. And I think the competition is now getting even more heated with the DeepSeek. And I think it helps everyone probably in the field and
Yeah.
also these companies to have these sort of competitions so that they can work on lowering the prices and then hiring and working on to increase the quality. So I think everyone benefits from this competition.
I agree. And Moin, let's deep dive into DeepSeek as the first item to talk about because it was definitely the most important piece of news last week. So I have prepared a few things to share. I'm pretty much sure that you have also prepared, and one of us can start and the other can comment on but we are going to see. So do you prefer to start or do you want me to go ahead?
Yeah, feel free to start. And I will probably. Do you want me to interrupt and add my comments at the time that you're
Yeah.
talking about, or just wait and then after?
Yeah, let's keep it like, a normal conversation. Let's just talk
Okay.
with each other because I guess there are lots of things to talk about. So let me share my screen here and make sure that you are seeing that. Okay. Can you see my screen now?
Yes. Yes, I'm seeing.
All right. Okay. So here is the GitHub repository for DeepSeek-R1 project. And it's quite, a resource, a very valuable resource of much information about DeepSeek. So DeepSeek is actually a model that came out last week for those who don't know, and this is a new large language model originally coming from China, and it's an open source, open weight family of model. I guess the only thing that they didn't share was the data that they trained the model on. But yeah, everything else is quite open source. And as you can see here, you have many different options to work with this model. You can chat with that in Discord. I believe they have basically an API, online API that you can try DeepSeek on your own. And this is basically the API for the entire family of DeepSeek models. If you want to specifically work with R1, you need to make this option enabled on the chat. And then you also have the option to search the web, which I didn't know about until I came and checked this API out. One thing that I remember I heard from one of these YouTubers, and Moin, please correct me if I'm wrong, is that the search capability is not going to be compatible with R1, so it's only for the older version of DeepSeek models. That's one thing
Mm,
I'm not quite sure about. At least here it doesn't give me an error, maybe we can ask it. Let me change my what is the best
yeah,
place?
I'm not sure about that comment. I'm not sure, but that could be the case.
Yeah.
Because in I saw this in the paper that the R1 model is not yet good at tool use. So because search is kind of a tool use basically, it probably is true what you heard.
Yeah, so let's see. So it seems that so it found 47 results. I tried to ask a question that is kind of related to a point ahead in time so that it doesn't have any way to basically hallucinate from its memory. So,
Mhm.
all right, no, I think it's not capable of doing a search because it seems that it's making a reasoning based on some found 47 results, which are the results of.
Maybe maybe the retrieval and the search is being done by the previous version of the model, and then when the new data is added to the context, then the whole prompt is given to the R1 to reason on it and then try to answer the question based on that.
Yeah, this makes sense. This makes sense. But regardless, I mean, we don't care about how they're doing that. Basically, if the API is capable of reasoning and searching the web at the same time, this is so cool. And as you see, it basically just gave me some sort of places to go
Mhm.
to. And based on the key events that is going to happen on that, for example, we have Rio Carnival, Feb 28 to March 8, and all other places with their own.
Yeah.
This is cool. This is very cool.
Pretty basic question. Can you see my video on the right side of your screen? Because I'm not seeing myself. I can see your video, but I'm not seeing
Yeah,
myself there.
I can't see your video at the moment. Yeah, I can.
So I hope it's getting being recorded.
Yeah, I think so.
Yeah.
So the problem that we had last time, Wayne, was that when you were sharing your screen, our
Mm.
faces were not.
My video wasn't available. But
So I did not touch the configurations this time. So at least in part of the videos that I'm sharing a screen, I believe that we will have both our faces at
okay.
the time, and hopefully it is not corrected when you share the screen as well. All
Okay.
right, so yeah, this is one thing, and then they have their models on Hugging Face if you're interested to go through there, and they have the models here. You can just download that. Obviously, these models are so large, I guess 690
Yeah.
billion parameters, so you probably cannot go and deploy these models on a regular local setup that you might have available, but still very nice of the authors that they basically open source the entire family of the model. And also, as we're going to speak about, the models that they use DeepSeek to a further DSTL, to basically to adjust compared to their baseline versions.
Yeah,
So
definitely.
yeah, so a couple of things, but no, things that actually caught my eyes was that first of all, with DeepSeek-R1, these group of researchers basically showed that you can use reinforcement learning without supervised fine-tuning as a preliminary step to come up with and reasoning type of model from scratch. And this is very interesting. And I believe they talked about an aha moment in models during models training, where the model finally realizes that the way that the reinforcement learning is pushing it, it needs to start doing some reasoning on its own to come up with the best answer. And this is so cool. So basically, you are not showing the model that you need to start acting like this kind of reasoning that we provided to you. You basically are just letting the model to figure out that it needs some sort of reasoning on its own. And this is what this was fascinating. I mean, I believe in the very final version of the DeepSeek that they released at the moment, they have eventually used supervised fine-tuning in some steps, but at least the founding baseline version of this DeepSeek R1 did not have any sort of fine-tuning when they were training that. They just used regular reinforcement learning. And some other researchers also showed that the type of the reinforcement learning algorithm does not matter that much. As far as you just let the model deal with some RL model, second model basically, and then it will finally learn how to do the reasoning on its own. And this was so cool. Do you have any opinion on this, Moin, or have you heard any complimentary kind of updates about that?
No, I was similarly fascinated by how this behavior was evolved in the model, and just to be clear on how this model is made, for maybe the audience can also catch up with the with this release, is that they started off from the one of the previous versions, which was only trained via self-supervised loss function, basically the autoregressive way that the models are trained. But as you mentioned, no supervised fine-tuning was done on that. So just to make the distinction that the model was not randomly initialized and
Yeah.
then directly going to reinforcement learning, the model had some basic knowledge of um, language and language modeling tasks, but instead of just going through the supervised fine tuning, which is a typical step in developing such models, they directly fine tune the model using reinforcement learning, which was, I think, the first open source version of it and the first paper that actually tells this kind of training models. Uh, and the fact that it works is really surprising. And yeah, I mean, the part of the paper they visualized this aha moment was kind of like very I
Very
don't know how to put it in words, but it was very shocking to see that the models can learn these kind of behavior just being exposed to how humans did this kind of reasoning in their text when the model was being pre-trained
yeah.
using a self-supervised loss function. And yeah, I mean, it was shocking the same way to me as well.
Yeah. So I actually opened the paper while you were explaining about this to show what exactly they did. So basically, you were referring to this DeepSeek R10 model. Am I right?
Yeah.
The one that.
Yeah, this is, I think, the version which is fine-tuned or trained with RL on top of the DeepSeek V3, which was the pre-trained version without any supervised fine-tuning.
Okay.
I
Okay.
think they mentioned V3 somewhere here, which was basically their model from less than a month ago.
Yeah. So they basically have. Oh, okay. So Harvard DeepSeek R10 encounters challenges such as poor readability and language mixing. To address these issues and further enhance reasoning performance, we introduced DeepSeek R1, which incorporates a small amount of cold start data and a multi-stage training pipeline. We begin by collecting thousands of cold start data to fine-tune the DeepSeek V3 base model. That's what you're referring to. And following this, we perform reasoning-oriented RL, like DeepSeek-R1 0. Okay, yeah. So basically, they have the DeepSeek V3 base model fine-tuned, and then on top of this, they start doing the RL. This kind of makes sense. So basically, they have a nice checkpoint, autoregressive model kind of checkpoint, and then on top of that, they teach the model to now answer the questions using reasoning, which is taught to the model by RL. Am I right?
Yeah, and I'm trying to find the screen here. And they did so because when they trained the model only using RL, as you mentioned in the first sentence, the model was mixing languages in the
Yeah.
thinking part of the output, and it wasn't that readable without the cold start data. And that after that, I think they reversed back one step, and then okay. And then they said, okay, we first fine-tune it a little bit using supervised fine-tuning just to teach the model how to use language properly. And then we fine-tune it further with reinforcement learning.
This is so cool, Moin. You actually raised a very nice point. I also wanted to talk about this. So this kind of behavior that people saw, I mean, the researchers saw from DeepSeek-R1 that it basically mixed languages during reasoning time. I believe some people had also observed with O1 kind of reasoning, or I'm not sure if it was O1 or O1 Purview or O1 Mini, but with one of those models, people also saw the same sort of behavior. So it seems that when you let the models to reason on their own, they are not necessarily going to be, only using one language. They are going to mix languages as needed. And then I was thinking about this, and I guess that kind of, I mean, if you look at how these models are trained, that might make some sort of sense, right? Because these models are trained on lots of data. Now you ask them a question, and they need to reason about your question. So they will probably try to make that part of their knowledge base that is most relevant to the question you asked. And that part of the knowledge base might come from, different people. I mean, just imagine the pre-training data with different people, with different kind of backgrounds, with different kind of languages in their written content. And now it seems that the model feels more comfortable to reason about certain aspects of knowledge in certain languages. And then as it is just reasoning for its own, it's not necessarily caring about the people who are reading that. It doesn't really care about, sticking to a certain language. It just switches languages as it helps it the most, and then finally gives us the result, as the output. So if we don't force the model to reason in English, the model is going to reason with whatever languages that is most helpful to his kind of thinking. That's what comes to my mind when I look at this very interesting finding.
Yeah, definitely. And it actually is the result of the environment that this RL agent is being trained in. I mean, they mention a few paragraphs further, I think, on how the reward is given to this model. I mean, in reinforcement learning, you're providing the model with some sort of reward and ask it, okay, to maximize this reward. And yeah, I think next page they formally mention,
Reward
yeah,
model.
the reward modeling.
Okay.
And the rewards here were for accuracy and formats. And for accuracy, because it's difficult to evaluate the LLM's responses in an automated way, they went for using coding and math as their main tasks for reasoning,
Okay.
so that they can easily verify if the final output is correct. For math, there's probably a number or a yes or no kind of thing as an output, and we can automate the verification, the evaluation of these sort of outputs easily. And then in code, again, it's easy to just run the code and see if that solves the problem it's given. And this way, during training, whenever the model outputs some generated answer, they can verify this answer in an automated manner so that the whole training pipeline could be done fast and doesn't need human in the loop or something like that. And the other reward is for cohering to this format they have made the model to follow, which they wanted to put their tokens, their reasoning tokens, in this thinking tags, and then the answer after those tags. I think there's a box at the top of these page that they mention how, yeah, here. There is a kind of a system prompt, and then they say put the reasoning process here, and then your answer here. And if the model follows this, it gets another reward. And the cool thing and the magical thing here is that these rewards are basically integers that are directly fed to the loss function. And the
Wow.
model tries to adjust its behavior to um, keep getting these sorts of rewards. And these are not very complicated ways of evaluating the responses of the model and giving this reward. This is basically a rule-based, as they mentioned, we adopt a rule-based reward system, and the model learns to how to make generations so that the reward is maximized. And it's cool to think of it as an RL agent, like, for example, reinforcement learning was previously and mainly used in kind of environments like games, and there was an agent
Oh,
there.
yeah.
The agent needed to interact with the environments, like go up, go left, shoot here, or take that I don't know, item from the ground. And you can think of this model, the LLM here, as the agent playing in an environment which is much more limited, and the actions are how to choose words or tokens. And these tokens could be added to the output sequence in a way that it maximizes the probability of the correct answer. So actually, the model needs to learn how to select those reasoning tokens. They could be nonsense tokens, but here they have made it to choose words from the vocabulary, so they make sentences. So the model needs to select tokens from the vocabulary and put that in the output context or output sequence, so that when the whole generated sequence is then fed back to the model to generate the next token, it is more probable to finally get to the correct answer. And
Makes
and
sense.
this is a, I mean, this is a very cool similarity between how this model selects actions, like those go up, go left, go
Yeah.
down, and shoot, in the environment of choosing words. So these words in the reasoning part could just be nonsense, or they don't have to follow any pattern. But the cool thing is that the model learns how to um, phrase these sentences to make the to increase the probability of the coming up with the correct answer. And the fact that it is readable is surprising, but yeah, they mentioned that it is not that readable because the model may cheat. It finds out during the training that if I use this token here, it doesn't have any specific meaning, but it increases the probability of coming up with the correct answer. So I use it anyway.
Yeah.
So I think that is one of the reasons why this pattern and behavior is seen in the model.
I mean, it makes sense, right? Because again, I think about these large language models and how they come up with an output with just imagining myself in a room full of many, many different objects and how I'm going to approach a certain object that is maybe in one corner of the room. And I'm just trying to find my way and, pave my path towards that corner. So I'm going to use any other objects that I see on my way towards that corner as kind of a help or as kind of a guide towards my goal. So those objects do not necessarily need to be the tokens or the words that make sense to people. It could be whatever that makes sense to the user. Say, for example, if most of the correct mathematical questions, the correct mathematical answers to a question that the user is not asking has come from very professional mathematicians that have used this kind of character, then I would say that if the model just uses this, then it's just kind of, prompting the next token to be taken from an area of tokens or a cluster of tokens that are more likely to be true, right? So I think
Yeah, yeah,
just basically trying to approximate how it can get closer and closer to the most accurate answer it needs to generate as the final output.
Yeah, definitely. And this is exactly because how these models are trained, these auto-regressive way that whenever a next token is being generated, all the previous context and also the previous generations of the models are fed so that the model can manipulate its behavior by trying to guess a few steps in the future. So it says, okay, if I use this and this and this, then I probably go in the right direction and I will come with the correct answer as you mentioned. So yeah, this is probably what is happening here.
Awesome, awesome. All right, so maybe take a look at another figure from this article, and then we can go back to the repo. But this is the aha moment that we mentioned earlier. So they are talking about how during one of the iterations, and while the model was answering one of the math questions, it figures that it needs to think a step by step. So basically, it's just a chain of thought that is now learned inherently by the model throughout the process of solving a single problem. So it's kind of very interesting, very, very interesting. Uh,
Yeah, definitely.
okay, so back to the repo, just a few other things to mention. First of all, the thing to mention is that this model's performance is amazing. So DeepSeek-R1 can be easily comparable to OpenAI O1 model, and we know that we don't have that much of data from O3. I mean, at least reliable data to compare these models against. But the O1 model is already out. The O1 preview and O1 mini are also out. And then you can compare the DeepSeek-R1 performance with this, which is very close. I mean, certainly outruns OpenAI O1 Mini in many different benchmarks and is on par with OpenAI O1, the version that was released on December 17th in many others as well. So it's a very cool performance. And the other thing, and the one that I really wanted to highlight is how cheap these models are. So let's see if I can find that. They had a diagram that it talked about the pricing, and I'm thinking that it was in the blog post that we
Um,
made or somewhere.
I think it was in the API documentation of DeepSeek. It was a separate page on their
Here.
website. No, it's not in the chat dashboard. You can Google it. DeepSeek AI documentation, API documentation. I think the figure that compares the prices to the OpenAIs and Anthropics are there.
Okay, so price comparison.
Yeah, I think um,
Yeah, it was a very nice one. Unfortunately, I lost maybe here
um,
models and pricing. Here maybe, or if not, maybe here.
yeah, I think
I think
not sure if
here, Moin. There we go. There.
yeah, here.
Okay.
Okay.
All right.
Yes.
So this kind of pricing is very crazy. So basically, if you're just using the DeepSeek R1 API from DeepSeek itself, you're gonna to pay $0.14 per million tokens, and then the regular output without caching is actually 2.19 per 1 million tokens. And if you just compare that with how much OpenAI is charging for O1 mini or O1 Pervy or O1, it's much, much cheaper. And I guess one thing that this DeepSeek R1 release proved is that we don't need to pay that much for
Exactly. Yeah.
inference time compute. And that is what OpenAI was dictating to everybody. Now, this model is showing that it's not that needed. And I really hope that after a while, OpenAI and other competitors, commercial competitors specifically, just lower their prices. But this was itself very cool.
And also that their whole budget for training this model was so much lower than even the engineer salaries of some of these companies, and that people were kind of commenting on this on X. And I had some posts to share afterwards.
Yeah, sure.
And I think the whole budget was $5.5 million, which is probably the salary of a senior engineer at Meta or OpenAI, which is really crazy. And yeah, I think this will probably make a big shift towards lowering the costs and making or rethink the whole process of why training these models was so much more expensive. I think the numbers are in the billions of dollars for training these pre-trained versions. There are also some other views that I think let's maybe share my screen on some of the posts here.
I will pass the steering wheel to you. Just give me 1 second. I'm going to. Can I start sharing here? There we go. Uh, can you share your screen now, or am I still sharing?
Yeah, I know. I think I can share my screen. Okay, are you seeing this?
Yes, I'm seeing your screen now.
Yeah, okay. So this was a post which was originally posted on Teamblind, which is a cool website actually that engineers and staff from companies can post their views blindly without their identity being leaked. But you can see their profile, like this person was in Meta, and I hope there's some process to verify that they were actually at that company. And they said that DeepSeek actually made a panic mode in Meta. And this is basically because of the much lower prices, both for training and, as you mentioned, for the API compared to what they are offering. And many other people commented that yeah, there's a similar pattern being seen in other big companies in the US. And yeah, here there was another take that DeepSeek could represent the biggest threat to US equity markets, as the company seems to have built a groundbreaking AI model at an extremely low price without having access to cutting edge chips.
Mm.
Yeah, and this was another important thing because there are, I think, limitations for exportation of NVIDIA chips to other countries that, I mean, not allied countries to the US. And this is another big question, that how could they achieve this without huge NVIDIA chips?
Yeah.
And there are kind of like other views on this, like what Dan Roy said, that um, I mean, he mentioned that because this team from China is illegally training their base model on all one samples, it was easy to achieve, but this is not something to praise or something that other companies in the US could do because they would be sued probably. And yeah, it was kind of like undermining the whole panic mode there. But just to see the opposing views on this, I think it helps to understand the situation better.
Yeah.
So
Kind of
the main message here is that this is a big news. So DeepSeek company is having its own ChatGPT moments probably, and as this leaderboard here, which I think is one of the most reliable metrics in the whole LLMs because it is based on human preferences and based on these ELO metrics, which, I mean, like in chess, that players can compete with each other and play against each other. These LLMs are fed with similar prompts, and the users then choose their preferences. So for example, they randomly choose GPT-4o and Claude Sonnet, and then the user decides which one is preferred blind to which model generated that sample. And this way, these models are ranked. And the cool thing is that DeepSeek-R1 is among the top three, which is, I think, a really important take from this.
yeah.
And yeah, I think no one can um, undermine the importance of this achievement, though there are, yeah, there could be discussions of how they could achieve this with such low prices.
Okay. So, Moin, I want to ask you to maybe stop sharing and share one more time. I was seeing your screen fine. The only thing is that it seems that my screen was also being shared at the same time. I believe we were recording your screen, but just to be sure, let's just share one more time before you go any forward to make sure that we are capturing everything. And yes,
Yeah,
I guess that kind of opinion that that guy mentioned, I mean, this is kind of unfair towards DeepSeek and how it actually achieved many milestones that O1 and other commercial test time inference kind of models could not do beforehand. And I just wanted to mention one thing. So maybe you also saw that, but there is one another type of paper that came out almost at the same time, I believe. Uh, so let's see if I can find the name here. Sky T1. Have you heard about this kind of model?
Yeah, I heard it, and I think they distilled one of the models on a smaller model, I think. I'm not sure, but I saw some post with introdu for an introduction of their model.
Yeah, so it seems that Sky T1, so they basically released two different models at the same time. So are you sharing your screen now?
No, and I'm not seeing your screen if
No,
you're
no,
sharing.
I'm not sharing. So let me quickly go back. So are you seeing it now?
Yes,
All right, so it's
but it's better if you can zoom in a little bit.
sure. Good point. Thank you. So it came from this account, Nova Sky, Next Generation Open Vision and AI. I guess that's the team behind these models, and they put together a model named a Sky T1 32 billion preview. Again, fully open source reasoning model that matches O1 preview on popular reasoning and coding benchmarks. Trained under $450, not even
Yeah,
100. This
this is
is
crazy. Yeah,
blowing, right? And I believe this came out almost around the same time that the DeepSeek-R1 model came out because they didn't mention DeepSeek-R1 at all. And I believe this post goes to yeah, January 10th, so maybe a little bit even before DeepSeek-R1, I believe. And then they did a very interesting job. I mean, the secret sauce to how they did this was that they basically put together a very, very clean training data set for training their model. So they're saying that the base model was Qwen 2.5 32 billion instruct. So they basically started from a checkpoint of one of these open source models, the Qwen family. And then they curated some training data from Qwen 32 billion model using GPT-4 Mini for reformatting and making sure that the reasoning and everything is super structured and every single data point in training set is as clean as possible. And then by only using 8 H100 GPUs and 19 hours of fine-tuning, better to say, they could convert this Qwen 32 billion model into a reasoning inference time kind of reasoning model that is now surpassing basically GPT-4, OpenAI O1 mini. So, I mean, if another team can do this at the same time, and if they can just come up with a training regimen, with a data pipeline that can help you have a very nice inference reasoning kind of model with $450. So why not to think that the DeepSeek people actually achieve that on their own and without stealing anybody's data? So I would say that this is a little bit unfair towards DeepSeek. And just to mention another interesting thing was that I believe the same team after basically, let's see if I can find the link here. I'm not sure if this is the right one, but I have this one here. Yeah. So the same people who actually put together the previous model, if I'm not wrong, they also, after the release of DeepSeek-R1, they used DeepSeek-R1 to distill another Nova Skies T1. I mean, using the Nova Skies T1 recipe, they now distilled DeepSeek-R1 model. And now they achieved another model that outperforms both Sky T1 and O1 previewing reasoning, right? And it is still 32 billion parameters. So it's even newer and more recent than DeepSeek-R1. So some folk from Nova Sky actually, released this model, the Sky T1 32 billion preview, which has a specific kind of training regimen in mind. Then DeepSeek-R1 was released, and then finally, this guy here, Mahesh, actually put together a DST version of DeepSeek-R1 with the same training regimen for Sky T1 and came up with this specific model that is called Bespoke, whatever, 32 billion parameter, and now it's actually outperforming, a Sky T1 O1 per view, and it's still a little bit down compared to performance of R1 itself. So it seems that people have found the way to do it, right? So it's basically a combination of training data And as we have explained multiple times, the cleaner the training data, it's much better. And the importance of the training data is probably higher than any kind of model architecture you could compete. And then afterwards, just de-escalating a bigger model, and then you can have these very astonishing performances. And the 32 billion parameter model means that now you can basically use these models on your own laptops, on your own local computes. And I believe DeepSeek itself also had distilled some open source models with different sizes. So basically now you have very, very powerful models that you can even run on your own laptops. So this was another example I just wanted to share with you, that this actually came after DeepSeek-R1 and again achieved very astonishing performance.
Yeah, thanks for sharing. And just to probably finish the section on DeepSeek, I just had some more highlights from the paper
Feel free to share.
that yeah, I wanted to share, and then probably we can move on to the next topics. The You can see the screen, yes?
Yes.
Okay. The interesting figure here was one of the other interesting figures from the paper was this one, which shows that during the training, actually the model learns to use this reasoning context or the lengths of those reasoning tokens more and more. So basically, it says that the model advantages from more thinking, which makes sense. I
Yeah.
mean, you are putting more computes to the model, not during training, this time during inference. So the fact that the model learns that it can change its behavior by using more and more tokens is another interesting fact. And as you mentioned before, that the model is using this anthropomorphic tone is kind of it has a a freaking kind of feeling, but I'm not going to mention that these things can literally think. But the way that I think using RL in forcing the models to come up with their own form of thinking, I mean, I think is a much better approach to just teach them how humans think. I mean, in the other approaches to teaching these models how to reason like chain of thought
Mm.
or think, let's think step by step, we are actually making the model to think as humans think, which I don't think would be the most efficient way of thinking. We just want to come up with the most efficient and the best working version of some process like our own thinking, but not exactly like that. That works well on silicon. And I think reinforcement learning can achieve that because it says, okay, maximize this reward no matter what. And the model comes with its own. And I think the more that the model is less readable and doesn't follow the way that humans think, it is more probable that it can come up with higher forms of thinking.
Yeah.
Because I don't think languages and words are the best way of processing things. And we probably cannot verbalize, if that's a word, our whole process of thinking. Probably there are lots of things that's going unconsciously, or there are lots of things that we are conscious of, but we can't find good words for it. And maybe that's the reason that these language models go for different languages to find their words and mixed languages, because the thing that they want to say is best represented in one language than in another language.
Yeah.
So I think this approach is probably going to be preferred over chain of thought or other approaches to enforce these models of thing because of probably examples like this one. And just to mention some final points on this.
Before
Yeah,
going further, just one thing. So that word anthropomorphic was quite hard.
fine.
So I just Googled that, and it seems that it refers to giving human characteristics, traits,
Yeah,
just to non-human entities, such as animals, objects, or obviously small. So I just wanted to clarify because I personally didn't know what does that mean. And the other thing is that the what you mentioned, moving towards non kind of have human looking way of reasoning actually makes a lot of sense from a cost standpoint as well, because it usually takes much compute and it usually needs more tokens to be generated when you are trying to make your reasoning be uh, human understandable. So if you can just let the model, to just use numbers, and those numbers could basically just represent some embeddings or some encodings of concepts, that would be probably much cheaper, if nothing else, only for the sake of using less tokens during inference time. So I guess, at least, if I mean, I think that we are going to have more and more models that basically rely on inference as an internal mechanism rather than as something to share with the user. And if they do so, then we can just let them reason with whatever ways that they like, and they will probably come up with more efficient ways of reasoning, and then hopefully with cheaper ways of reasoning for us as well. And if we need to see everything as interpretable as with these kind of models, then yeah, we need them to reason using human languages and be consistent in the language they choose and things like that. But as you mentioned, I don't think it's necessary. We just basically can let the models reason on its own with whatever ways that it suits better for the case, and then we just look at the output and rely on the output.
Yes, I agree, and I think this is closer to the way that OpenAI is doing it in O1. I think they had some tokens for reasoning that were not human readable. And as you know, the when the O1 is basically thinking, they're not showing the output because that is not human readable, or they don't want to show it probably, which makes it a little bit secret, and the developers don't know what they are paying for because those tokens are actually counted in the pricing. Um, but yeah, I totally agree that we can probably expand the vocabulary and just introduce some randomly initialized tokens and tell the model use these tokens as you wish, and just assign them some meaning, some sort of handles that you want to use in your inference as you wish. The only important thing is that adding that token um, prior to the coming up with the full answer increases the probability of coming up with the full answer. And just having this condition in the whole training, which takes probably lots of hours, it teaches the model on how they wish to use those tokens. And those tokens could have no meaning or some meaning, and you can do all sorts of interpretable things to see what those probably mean, but we will probably never find out. But yeah, I think not making the model to only follow tokens that come in the language vocabulary probably is helpful. I don't have lots of evidence for that, but this is just my internal feeling. Just some um, quick points here. If people want to use DeepSeek, I think the most important point here is this one on prompt engineering, and is that they observed that DeepSeek-R1 is sensitive to prompts, which is another important point. And they said that few-shot prompting consistently degrades its performance,
Okay.
which is, I think, the most,
Yeah.
the boldest different thing to this model compared to other models, because in my experience, always adding examples to the prompt works much better. Even it works better than explaining the task. Just giving it some samples and examples probably works better than just explaining how to solve the task. But they say that it degrades its performance, which is probably because they're not trained with supervised fine tuning, and the RL training discourages these sorts of prompting. And yeah, I think this was it. And here they mentioned that the capabilities of DeepSeek R1 fall short of DeepSeek V3, which was kind of like their GPT-4o model, not the reasoning type, but a good, helpful model that could be used as a chatbot. And in tasks like function calling, multi-turn complex role playing, and JSON output, this R1 model is not yet as good, but probably soon we will see lots of upgrades to that. I think this was it, and also just some final takes on this one is that um, DeepSeek-R1 is not a dense model, it's a mixture of experts. So not all these 671 billion parameters are activated at every time. Based on which trajectory the model chooses to go to, the maximum number of activated parameters at each moment is 37 billion parameters, which is, I think, very low number, uh, given its capabilities. And the context length is 128K. And these are the distilled models uh, using the R1 samples. And I think another trend that this paper and this model will um, help start is showing the effectiveness of distilling.
Mhm.
And before that, I wasn't sure that fine-tuning on lower number of samples could be this effective, but they showed in this paper that a 1.5 billion model, a parameter model could actually outperform lots of bigger models. And they open source these models as well. And I think, yeah, that's it. And just to, as you mentioned, to share my screen again, because it might not be shared the previous time. This was the LM Arena website, which I think is one of the most reliable um, benchmarks or evaluations for these models because it is directly from human preferences and there could be no leaks or whatever because they're just models competing each other. And these were the tweets and posts I shared a bit earlier just to make sure that they're recorded.
Awesome. Thank you very much. It was very nice of you to review all these. And maybe just two last things about DeepSeek before we advance. First thing is that, so I guess one problem that I usually have with DeepSeek family of models, even before R1 and now with R1, is that they don't natively support the structured outputs. So if you just try to use these models with Light LLM, which is a Python package for, basically working with all these large language models from different companies using the same syntax, unfortunately, you cannot control the structured outputs of DeepSeek models. I mean, there are some sort of third-party libraries that can stand on top of DeepSeek and try to force it to have an output as you like, but I guess this is not as efficient as just having the model structure. Structure is output based on the user preference. So that's something that hopefully the researchers behind DeepSeek could address in future. And then
Yeah, definitely.
the last point is that this is quite a fun point. You know that DeepSeek-R1, despite being open source and open, but it's still censored. So if you just go to the API,
Yeah.
read about Taiwan, for example, considering that it comes out of China, it doesn't even reason about that. It just says that Taiwan is part of China, has always been part of China, will remain part of China, and things like that. So again, I guess that we need to wait for a little bit on more uncensored version of the model to come out soon, as people usually do with the other kind of open source models that these big companies share. And unfortunately, censorship is from everywhere, US, China, everywhere people have noticed different sorts of information censored in these models and or maybe hard coded in their knowledge. All right.
Yeah. Um,
Yeah, please.
Thanks for adding these final points. And I totally agree that no matter which model you use, there is some sort of censorship in it. And this is probably one of the sad points, but we can get past that um, um, for the advantage of that these people are actually doing and making these models. And we can tolerate that part probably
Yeah,
in because they're doing such good things in general.
I agree. I agree. All right, so we have spoke for, I guess, a significant amount of time, about 30 minutes, 40 minutes, I guess, about DeepSeek-R1, and it really deserved this amount of discussion because that was such a huge milestone in the evolution of LLMs. Now we can jump into other topics that we have. I deliberately did not put too many topics together for today because I knew that we are going to talk a lot about DeepSeek. So do you want to take the lead on the next topic, Moin, and then I can follow after you?
Yeah, sure. Same here. I didn't pick lots of topics, and for the next ones, I will be much. go less in depth or just superficially introduced it and probably pass that.
Right.
And one reason is that I didn't have the time to go in depth, and the other one is that if you want to do so, we will be recording this for 3 hours probably. So let's go to the next one. Okay. I hope
Yeah,
it is
man.
being shared here. Okay. Um, this was another new paper, 17th of January, and it's called PaSa, an LLM agent for comprehensive academic paper search. And it comes with a good demo. And the cool thing is that the affiliation is ByteDance, which is the company behind TikTok, and they're doing research on academic paper search, which is kind of funny.
Okay.
Um, yeah, they introduced paper search. I'm not sure why my highlights are not being shown here. Yeah, here they come. Okay, and I think the pipeline is best visualized in their figure one. They actually come up with an agentic pipeline to search and select papers based on some query, some um, scientific or academic query on based on what papers the user wants. And there is a crawler, which is basically an agent, and so probably LLM powered. It has access to a search tool, which is Google Scholar, other search engines. And it can also go through the paper to the references and then expand those references and then go to those references, kind of like a graph or traversing like a tree of references. And then it can decide if it wants to stop checking that paper. And then this crawler adds papers that it had found. At this stage, it doesn't check for its relevance that much. It adds these papers to a queue, and then there's another agent that goes over this queue and then selects the papers that are relevant to the query. So this is, I think, very generic and kind of expected. The other cool thing, which is, I think, the common theme of this week of research, was that um, and we optimize PaSa using reinforcement learning again. So this whole process is trained in a reinforcement learning environment using synthesized data. So they chose or they came up with some scientific queries, and then they synthetically found some preferences and desired kind of papers that are relevant to that query, and they go through the process of how they did so, and rewarded the model as for whenever it came up with a similar list of papers for that query.
Mhm.
So again, this was trained using reinforcement learning. And then they also introduced this benchmark, the real scholar query, to benchmark further works in this area of academic search, which is, I think, another cool thing for this paper. And they found that their model is doing much better than the vanilla Google Scholar search, even GPT-4 powered searches, whether dashboard or whether UI or other tools. So this is probably something that we want to have an eye on how it works. And this is their demo. And you can go on and search, for example, show me the latest research on self-supervised learning in vision. I mean, I'm thinking of works like Clear and Clip and probably Dino, and I just want to know what are the latest works in their like mass language, mass also encoders, MAEs, and it starts searching and it adds the cool thing is that the list is being added to it doesn't wait until all the results are ready, so you can go through the results here. And I think they make sense at the first view. Let's see. Self-supervised learning for detection through mass bounding box reconstruction, which is for the end of 2023, not that recent, but still good. And
But there is a button on
um,
the right-hand corner that you could probably force it to only pull results from since 2024.
yeah. Probably, let's click on that since 2024. What are the latest works in this area? Yeah, this was for 6 or 7 months ago. So, not sure how useful it would be at this stage, but I think we will see more and more of these kind of tools, and it's really good that they are introducing benchmarks for it so that there is a coherent way to compare them. It's not just based on the feeling that every user gets. And yeah, this was another thing that I wanted to introduce.
So, Moin, just a quick comment
Mm,
on this. I also
yeah.
see this paper. I also saw this paper and went through that a little bit. Didn't read it in full, but did try to skim it a couple of times. So this is a very interesting paper, and you know that I'm kind of interested in this topic as a whole because of the latter review package that you and I worked on. The thing is, I mean, I was looking at the way that they approach the problem, and just a fundamental kind of philosophical question came to my mind that how much do we want to uh, basically automate the entire process of reviewing the literature as a reinvention of the wheel, or how much do we want to basically try to automate the current established workflow? So what I mean is that the way that they are trying to do this workflow is that they are trying to bypass all the steps that people usually do when they are going to systematically dig the literature, right? You know, they don't go through the titles, abstracts, things like that. They directly jump into the papers, and there is only one agent that automatically extracts all the information out for you. And this is very cool because this is very fast. This basically gives you a very nice understanding of the big picture in the literature. At the same time, some people might reason that the way that we used to do this in the past since the time that we basically went through the articles, we came up with some queries, extract the articles out of some search engines like PubMed, or databases like Scopus or Scholar, and then we put together a pool of data, looked at the titles, looked at the abstracts. Usually more than one researcher or usually more than one reviewer looks at the data and then try to talk with each other, maybe have a discussion about those more edge cases. And then finally, people go and do a full text review of the paper. And that's the time that they finally come up with a very clean list of papers. And for things like, for example, forcing yourself to a specific period in time, you might not even need to rely on an LLM. You can basically just use some of the tools that the current search engines offer you, and then you can use that, and then it's going to force you to at least do the search very nicely. So I'm thinking that, how much do we need to reinvent the wheel for a use case like this, and how much do we need to automate the already existing workflow, which I believe latter review kind of fall mostly in the latter category rather than the first one, and this PaSa mostly falls into the former category. I don't have a
Mhm.
clear-cut answer to this question, and I guess finally we might need to see which of these two type of solutions are going to take the word, but we need to find the sweet spot between coming up with AI agents that are completely new and work on their own in their own kind of world, or the ones that are going to basically adapt to our own kind of world, to the one that we already have built for humans to live in, and now they need to also comply with the same world. I have no answer to that question.
Hmm. I think it totally depends on what is the final purpose of using such tools. I think for doing systematic reviews and meta-analysis, of course, it doesn't make sense to use this one because it doesn't follow any of the solid guidelines that we how to do these papers for so many years. The way I was thinking about this tool and how it could be useful is that at least they showed I mean, it depends on how reliable the benchmark is. At least they have showed that this engine is working better than Google Scholar Search itself at finding some of the first and most useful results to a query, and you don't have to search with keywords. You can write sentences, which is a cool thing. So I'm thinking instead of just going to Google Scholar when I have a question and find the relevant papers, I will probably prefer to use this one.
Mhm.
Um, I mean, at the current stage, maybe further down the road it gets better or even worse. But I think it depends on how these tools are going to be used for what purpose. Um, of course, at this stage, these are probably only good for kind
Quick.
of like
Yeah.
yeah, quick searches just to find some of the most relevant papers without going through the 4 pages of Google Scholar or other search engines. And I don't think either that these tools could be integrated in the whole pipeline of generating new scientific papers. And I don't think they encourage people to do so. I'm not sure. I haven't read the paper in full, but I hope they haven't encouraged for such a use case.
I hope too. Yeah, and basically the question you put there was kind of interesting. The one that you asked about self-supervised learning with imaging data, that kind of leads me towards one of the papers I wanted to introduce today. The name of that paper is X-sample contrastive loss. I'm not sure if you're seeing that.
Yeah, the cross at the first of the title,
Yeah,
I
yeah.
think.
And
Yes.
the query
Uh,
you just put into PaSa could find that one, could retrieve that one.
Let me see. I think it's 2024. Yes.
That paper, no, it's quite new. Let me tell you when it was first published. So
Oh, so
not new. It's not new, sorry. It's for 11, September 11, 2024.
okay, so it should be in this 2024 list, but no, I can't see it here.
Okay. That's interesting. It's in September. I guess the first version of that was for that time. I'm not sure why I had not seen that before. So it's not quite it's
And
quite
I think it's from the Meta lab with Jan LeCun or one of his
it's
PhDs, I
from
think.
Meta. Yeah, it's from Meta and
Yeah.
he's a senior author. Yeah.
Yeah.
Yeah. Okay.
I also read that in the last week, but I didn't cover this in here. But yeah, definitely share it and see how we go.
Yeah, we can share that, but now that you said, I'm just wondering why this paper came to our feeds last week while it has been published on September 2024. It's kind of interesting.
Yeah.
Okay, so let me quickly share that one and then maybe jump to that one. All right. Are you seeing this?
Yes.
There we go. Okay, so I'm gonna be very quick with this one because I guess we spent too much time on DeepSeek, but basically the name of the paper is X sample contrastive loss. I'm very happy that this one is not about large language models because I guess the world is just being dominated by those models, and we need to talk about other advancements in deep learning as well. So, as you mentioned, Moin, this is out of Meta Lab and Jan LeCun's team. And as we know, how he is interested in self-supervised learning, this paper is again about self-supervised learning and maybe a better technique for coming up with a contrastive loss. So, contrastive loss, if people are aware of, this is a loss that we usually use in self-supervised learning training paradigms in order to train a model that has some sort of basic understanding about the field without necessitating us to give it labeled data during training. So it's self-supervised as the name applies. And now the way that this specific paper works can be easily summarized into this single figure. So they're saying that, in contrary to the conventional contrastive loss, which losses like SimCLR were based on, that basically assigned a 0 or 1 kind of answer to whether or not two pairs of imaging data were similar. Now they are making this similarity score continuous. They're saying that, I am not saying that these two images are exactly similar. I'm not going to say that these two images are exactly, dissimilar or different. no, there are some sort of similarities that could basically be quantified here. So rather than just assigning a score of 0 to these different pictures of a cat and a dog, and maybe just assigning a score of 1 in terms of similarity to these two figures of two dogs, we can basically quantify that. And they say that, the more you can come up with the notion of quantifying this similarity, the better your loss is going to be. So, for example, if you're dealing with natural photographs like these, you have lots of models that can basically describe these images for you in textual format. And then you can just simply convert those textual responses into quantifiable scores that are then going to be a continuous range of scores rather than a 0 to 1 score. And then you can use those as kind of scoring for assigning a similarity score between to each pair of images like these. And this is and they show that this is going to make a more knowledgeable kind of self-supervised model compared to just forcing the model to assign either 0 or 1 to either of the pairs that it sees during the training. And then they come up with a kind of an evaluation that basically summarizes their findings. And I believe, so these are different self-supervised learning methods that they have highlighted. I believe if we just look at this row that is comparing the conventional SIM-CLR, which I guess was the first paper that leveraged contrastive learning in a very nice way, and then this XCLR, which is their proposal, we see that, looking at different data sets, the XCLR is going to have a better performance compared to SIM-CLR, which is basically just showing us the power of making the scoring mechanism a little bit more flexible, a little bit more liberal, and then having the model learn more from that. I guess the bottleneck to this approach is how to come up with this sort of quantifiable scores about the similarity of the pairs of images. And again, in case of natural photographs, you have the text data, and they are simply showing how the algorithm works. They just takes the softmax of the image similarity and the image embeddings, and they also take the softmax of text embeddings and then make the cross entropy between the two, which is a very nice way. The question is, how can you basically come up with some sort of similar notion of similarity like these text embeddings in cases that you don't have any kind of textual descriptions of your photographs or images available. And they talk about how, for example, in biological domains or medical domains, you can rely on some sort of metadata that you have available for those imaging data to, again, kind of mimic this textual data and then try to come up with similarity scores on top of that. So the way that I gave myself an example here was that, say, for example, if you have two different brain MRI scans, and if you have, for example, two different CT scans available from different patients, the two brain MRIs are not necessarily going to receive a score of 1 in terms of similarity if you are just training a self-supervised model on a bunch of CT and MR data. But if, for example, the two patients that you have the MRIs from are from, same sex, or if they are falling into same category of age, maybe then their similarity scores is going to be a little bit higher. Or maybe if the views of those MRIs are going to be similar, the similarity score is going to be higher compared to the time that, for example, you have two MRIs of two different patients that are, one is very juvenile, the other one is very old. One is a male, the other is a female. So these should naturally receive a lower score of similarity. So I guess we can do tricks like that, things that we can extract out of the DICOM metadata and things like this to make the implementation of contrastive loss a little bit easier and maybe a little closer to the innovation that they did here. But again, unfortunately, it's going to be difficult to come up with something as accurate as a textual description of some medical imaging compared to national photographs. This is at least my understanding. Now, Moin, you told me that you also went through this paper, so I'm excited to hear what you think about this.
Hmm. Yeah, sure. At first, thanks for explaining the paper,
Yeah.
and I'm on the same page with you, and agree that um, just providing those 0 or 1 signals to the model is not that helpful when there are actually similarities between the models, between the samples. and the model needs to go through probably lots and lots of samples to finally learn, okay, these two also have some similarities, and I shouldn't just disregard all these similarities. And yeah, the way to feed this information to the model uh, is probably very different and very difficult. That even at the end of last year, we have still works publishing at this important question of how to feed these similarities, and also tell the model, okay, these are actually different, not that different, and make that a continuous thing compared to the binary yes or no or 0 or 1 signals. The only thing that's probably made me decide not to cover this here was exactly the table that you shared. If you can go to that
Yeah.
again, is that compared to the performance of the SupCon method, which I think was for a little bit after the clip paper was released, so probably 2022 or maybe at the end of 2021. As you can see, the results, it's not that much improved. And I think for such a paper that introduces so much complexities and makes the loss function is much more complicated, with something like SupCon, which is a very simple approach to contrastive learning. It is, as far as I remember, it's very similar to SimClear, how it works. Sorry, I think I mentioned clip first. But it uses the information of the ImageNet classes when training,
Yeah.
or the data sets that is training on it. So they're going down this rabbit hole of adding lots of complexities, but their performance is not that much improved to that. So I think that was the drawback I got from the paper. Of course, their methodology makes a lot of sense and it will be improved. And it was, of course, worth publishing, but not maybe acting like a step function in the improved performance of the model. That's just probably a little got to me.
So,
But beside that, the methodology seems very logical to me.
so Moin, maybe I can, defend this paper a little bit here about this comparison.
Yeah, yeah, sure.
So this SupCon method, as far as I understand, I don't remember the paper exactly, but based on the explanations that they have provided here, this is the supervised contrastive. So
Yes,
they basically, in SupCon method, if I'm not wrong, they used ImageNet labels. So it was not
yes.
self-supervised. So I think that what they have shown here is that a self-supervised method could be as good as, or maybe even slightly better as a supervised contrastive method, which, if you can just set a pipeline like this, then it basically means that you are going to bypass lots of manual efforts in labeling images, because ImageNet was labeled and they use those labels, human generated labels, for just coming up with SupCon. And now a self-supervised method, which did not use those labels, but as you mentioned, relied on some complexity that automated everything, now is going to achieve a better score. So I would say that if they are proving that the self-supervised method could be on par with a supervised contrastive method, I still give them the credit for coming up with something nice. What do you think about this?
Um, Definitely, this is something that we sure need to take into account. Um, Again, the way I compared these two things, it was that this cross CLR or XLR, whatever pronunciation we should assign it. I think it's still, as far as I understood, it still uses metadata, like what is the broader category of this thing. I mean, if you can go to the first figure, um, they explain that. I mean, this was the hard part to understand how they are coming up with these similarities. But as far as I understood, there are some metadata related to these images, and they are kind of like building some sorts of graphs of how these items are related to each other. And The farther they are in that graph, the score of similarity is lower. And coming up with that graph from the metadata, I think it's kind of like making it in a supervised manner. I'm not sure if this is actually what is being done here, but it is what I remember from reading it a little bit ago, a few days ago. And so I thought maybe it's fair to compare that to, um, I mean, ImageNet or, I mean, the supervised contrastive paper, which use ImageNet labels. But yeah, this is done all automatically and in a self-supervised manner. It is not relying on labels. It uses metadata fine, but it uses in an automated manner. That is, of course, the credit we should give the paper. But yeah, this was my view on why I compared that to that paper, and I'm not sure if I'm right in what I understood from the paper and how they did what they did.
No, you raised a nice point. So it seems that you were referring to this part of the paper. We experiment this new objective called X-sample contrastive by training vision models using a graph of similarities inferred from class or text caption descriptions found in common data sets. So now I agree. If they basically use those manually generated human labeled classes, then they are not going to add that much of value compared to SubCon. But if everything they did was based on the captions of the images, which that was my first understanding looking at this pseudocode here, that they are just using the images and captions and nothing more. The captions could come from whatever, image captioning models. Again, LLM generated, so captions could be, wrong as well, but they still managed to figure some useful signal out of those captions. That makes the work valuable. But if they're using some of those labels that ImageNet has, and those labels, as we know very good, are human generated, then yeah, I agree with you that this is not as useful as how SubCon actually put together its algorithm. So that's actually a question to go and read the paper in detail and find the answer to, but that's a very good question, Mark, you raised there, mate.
Definitely, and probably the paper has some explanations of how they defend their work compared to other contrastive or other supervised contrastive methods. But I just went through the abstract and the first part of the methodology, and then I found it's a very complicated paper, and I
Is.
prefer not to go much deep into it.
Yeah. Yeah, again, so this is something that we should probably go and read a little bit more in details and find out whether or not it's going to be useful in practice. But still, this idea of making the similarity scores a little bit more flexible and less constrained to either 0 or 1 boundaries is something that I guess we can rely on for some future experiments. Nice one. Okay,
And
all right. So I'm going to pass the ball back to you if you have any more papers to go through.
yeah, mostly tools that I wanted to introduce. No more paper, or maybe one more paper.
Yeah,
So okay,
me too. So let's finish your round then. Go through the tools and that one paper, and I also have one more, I mean, two more papers to show and two courses to show.
okay, great. Let me share my screen, and this will be quick.
Okay.
um, Intros to some tools. I found this one maybe a few minutes before we start. I was searching for another thing, and then I found this website. There is an AI for that. This is a good tool when you know there should be some AI-powered application to do something, but you don't know where to look for it. And it uses AI to find those AIs, which is crazy, and I think adds the complexity, but it comes with a user kind of friendly user interface. You can search here, and then it lists the relevant AI-powered tools to solve that task. I'm not sure how good this works because I tried it for some queries and it wasn't that good. But maybe
I'm not
I
intrigued. Just go and put Akash
yeah,
paper search there because I just want to know if there are anything comparable to letter review there.
Okay, let me search for tools for automating the
Academic, yeah,
academic review process, maybe.
yeah. I feel also
Uh,
maybe include some peer review tool cases as well rather than literature review, but it's okay. Let's see what it finds. But what team has built this website? Do you know who are the people behind it?
no, but I can check. Anything about the team, any about us or something?
Yeah, this is cool. I mean, I just really want to give credit to people who did that.
Yeah, it's it's like the systematic review in the academic world. Let's see, it is still searching. So
Good searching. At least,
the
um,
co yeah.
I mean, it's promising. I think that at least there are no immediate solutions that came to its mind. I'm happy about that.
Yeah, I'm not sure whether it's because of my internet connection or it's actually searching. So I hope it is really searching. The cool features in the meanwhile it is searching that I saw here was that it there is some ranking based on people votes so that you can go through the best kind of AI-powered applications and see what are they doing. I think it is not working. So if you agree, I just um, go to the this page here. And there were some new applications that I hadn't heard before introduced here. I mean, the first one, of course, is ChatGPT, but this free pick AI generator is number two among all these agents. I haven't tested this, but I mean, I just found this a few minutes before, so I didn't have the chance to go over the applications. But there are some new things that seem promising, like this edit app, Notebook LM, Perplexity. I think everyone knows about them, and also Suno. And but there are some new things that are probably worth going through and see what they are. And there is some trending um, tab and feature here, which is very good probably to find the newest and latest useful AI applications. I mean, I think this will be one of the websites I will check frequently in the next few
Yeah,
weeks.
certainly, certainly. It's very nice. It's a very nice one. And I guess I'm just trying to set that up for myself, and it has many different categories that you could be interested in. So it's not only about apps, you could also think about prompts and many different applications that you could come up with. It's a very nice one. I really
Yeah.
like this.
So this was one tool, and then the other one was this website that I think I introduced to you a bit back, but this Roadmap.sh website is I think a very valuable resource in these days that there are lots of educational material for any um, career pathway or any sort of name you want to assign it. And this is basically a compilation of some of the uh, high quality and best ranked educational materials to go through that career pathway. So, for example, for AI engineer, I was actually looking for the AI engineering roadmap on what things should someone know to be able to do well as an AI engineer role. And it introduces this whole flow chart kind of thing that says, okay, you want to first know about what is the differences between an AI engineer and what is the difference between an ML engineer. And there are some courses it introduces. Some of them are free, some of them are premium. So for each of these boxes, if you click on it, there is some recommended resources on how to learn that topic. So, for example, let's check what are the
Moin? So it seems that I lost Moin's connection. So let me pause the video for a second and make sure that it's back.
Yes.
All right. Okay. So I just
Yeah.
paused the recordings for a second that you were out and now you're back. You can share the screen again and continue.
Yeah. Okay. I hope it works fine for
Yeah.
mixing the
I
yeah.
just paused the recording. I didn't stop that, so it's gonna be one single file of recording.
Oh, okay. Great. So, okay, I was here. I don't know what happened. I
Yeah,
kicked out
you were
of the.
talking about that AI
Mhm.
pathway, AI engineer pathway, and then when you
Yeah,
were
yeah. I'm going to
about
share
to click on
reshare my screen. I hope it is visible now.
not yet. I'm trying to see.
Can you see it?
Not yet. It's still not showing to me. Let's see if you have, I guess you have the permissions to share, right? Yeah, you do have the permissions. Wayne, can you hear me?
Okay.
So it seems that your recording is running into some issues. So not sure what it is. If you want, I can share the page that you were trying to show. Maybe if you can just send me the link in the chat, I can share my screen and then,
Yeah, definitely. I will send it here.
all right. Let's,
Yeah, as soon as I share my screen, it
yeah,
kicks me out, and I don't know why.
no worries. Let me quickly share my screen. Can you see my screen now? Moin? Moin, can you see my screen? Moin?
Yeah,
Yeah, did you see my
what
screen
happened?
for that?
No.
So let me try one
Uh,
time. And if it didn't work, then we probably need to call it a day and start another meeting. So let me do that one more time. Uh,
okay.
so this is going to be this one, I believe. Can you see it now?
Yes, yes, it is
All
being
right.
shared.
Okay, so it's fixed now. Okay, perfect.
Yeah.
All right,
Can
so
you zoom in a little bit?
sure, sure. Okay.
Yeah.
Uh,
So
let's see.
for any of these career paths like AI engineer or data scientist, there's a kind of like this flow chart of um, these sorted materials that a newcomer should uh, learn in order, somewhat in order, so that they can follow with the that career pathway. And for any of those boxes, if you click on them, there's a list of resources. Some of them are free, some of them are premium. And I think this is a good compilation of all the materials there is out there to just start from somewhere and learn about a role, about a career path for like an AI engineer.
That is very cool. And correct me if I'm wrong, these pathways are not AI generated, right? So they are
No,
basically
no.
created
I
by.
think there are yeah, I think at first there is maybe probably um, I don't know how to put it, um, a preferred roadmap by maybe someone, but it could be improved by the community. So it is a community-driven roadmap. People can introduce their own resources, and if it gets approved, it would be added to the page. I think it works something like that.
Okay.
And
Awesome.
if you can, yeah, if you can go to the first page of the roadmap message, there is a whole list of the career pathways that they offer. Like, for example, backend, full stack. I think it was the previous page.
Oh, okay. Sorry. I clicked too soon. This is
No.
start here. I can go here.
I mean, yeah, you can just go to the URL and yeah, here, this one. Yeah. And then, yeah, for front end, back end, DevOps, AI and data scientist, software architect, for each of these career pathways, they introduce some roadmaps, which is a good way to know which topics people should learn. And then for each of those topics, they introduce some educational materials on where to follow, how to, what to read. And I think it's a valuable resource for anyone who wants to enter any of these fields.
It certainly is. It's already caught my eyes in many of these different topics that is here. It's very nice fun. Very, very nice fun. Okay. Yeah, that's very useful resource, and I guess we all are gonna learn a lot about this. Cool.
Yeah.
Yeah.
And
What other?
I think for the last thing,
Okay.
I wanted to share this one. I think I will send the link in the chat so that you can share.
Oh, cool. Yeah. Let's see. So this is the
This one has a really cool name, and I will. Um,
exam.ai. I like that. Okay.
Humanity's last exam. This is kind of their clickbait name that they have assigned to this new data set. But I think it addresses a very important issue, and that is that most of the LLMs today are saturated for the current benchmarks like MMLU, which is another benchmark for evaluating these LLMs. And they came up with 3,000 new questions, which are very difficult and complicated, mostly academic questions that need reasoning mostly on and evaluated the most recent models on these 3,000 questions. And they in the next paragraph they say that these questions are nearly from 1,000 subject experts affiliated with over 500 institutions across 50 countries. So
Uh,
it is a collective work. Yeah, here this one. And there and these experts are mostly comprised of professors, researchers, and graduates degree holders. So the questions are basically mostly academic. So the performance of these LLMs on them is probably a notion of how academically good they are. Not it probably doesn't evaluate the overall performance of the model on summarization or anything. But I think it's a very good effort on providing new benchmarks for these models. And as you can see in the quantitative results down this box, most of the models are performing very badly on this. I mean, 3% for GPT-4o and 6.2, 9.1 for O1 and 9.4 for DeepSeek-R1. So basically all the current models are doing less than 10% accuracy on this one, which is some um, good thing to have in mind that probably a year later, all of these models will be doing over 50% and start saturating. But another cool thing is that they also calculated the confidence and the calibration error of the answers that these models give to these questions. And as you see in the left part of the screen, to measure calibration, we prompt models to provide both an answer and their confidence from 0 to 100%. So not only that the previous models are doing very bad on this benchmark in terms of accuracy, they're overconfident.
yeah.
For example, O1 is 93% confident that it's
Inaccurate.
correctly answering. And the good thing is that DeepSeek R1 is outperforming others and also has a less calibration error. It's still very high, but at least it's less than the other ones.
Yeah.
And yeah, I think this is a really valuable new benchmark that is came out, and I think they spent a lot of money on making this new questions. I don't remember exactly um, how much, but if you can click on the paper, the link um,
Hmm.
on the top of this screen.
Okay. Let me just find that. Oh, this is the one. Okay.
Yeah, and in figure three, they show the distribution of the questions, and
Sorry,
on page six,
I
on
was
page six.
caught off guard with the number of contributors to this data set.
Yeah,
This is amazing. All right. So page 6 you mentioned. This is page 6. Okay.
Um,
Is this the figure you're in?
yeah, this one.
Okay.
Yeah, the figure three. 11% of the questions are from the field of biology and medicine.
Mhm.
Most of it is from maths. Yeah, we should take this into account when seeing the performance numbers of the models. Only 10% of the questions are from medicine, and most of the questions are math and physics, if you can. I mean, yeah, it's more than 50%. So the majority is math and physics.
I mean,
Yeah.
so what something that is actually quite interesting to me is to understand how much human experts have performed on this data set. They reported any metrics for that?
I don't think so. I'm not sure. I mean, an average human being probably won't be
Yeah, I,
able
I
to
think
do
average
any of it.
is gonna be less than 2 or 3% on these kind of questions. I mean, the questions, I was just looking at
Yeah,
the examples. These look brutal. I mean, what kind of questions?
yeah, of course. Yeah, I mean, these are the kind of the most complicated and reasoning requiring questions that those people could come up with. So, yeah, these are not going to be easy for an average human being.
Anyways, but I'm very happy that now we have another benchmark to have an eye on, especially for these.
Yeah.
Models.
Another another cool figure is figure 5, which is kind of funny. They counted the average completion tokens,
Okay.
which is both reasoning tokens and the answer. And I think maybe one of the results one could draw from this figure is that uh, biology and medicine for all of these models requires the least reasoning. So it's probably mostly about retrieving the
Yeah.
correct facts just to answer. But for something like math and physics, you see the most tokens are used, which makes sense. You need to go through lots of reasoning and logic to come up with the answer.
Yeah.
But it's really funny that medicine doesn't
Yeah.
require that much
And
of
I guess
reasoning to come up
and I
with the
guess
answer.
reflects on the fact that we know very little about biology or medicine in general as well. Because, if these models have been, I mean, these models are not guilty. They have been trained on the data that we have available on the internet. And if they have not learned how to reason about biology and medicine, that probably means that our approach towards these fields are either wrong or either very primitive. I mean, we still don't know too many things, deep things about what is going on in biology and medicine. And I guess it's mostly the latter case. The way that we think about biology and medicine is that it's just a collection of facts, whereas the
Yeah,
way that I always love to think about medicine and biology is that they are still explainable by math. So they should not be in nature different from the math column here. But the math that is required to explain biology and medicine is far different from the math that we are used to, and probably it's just a
yeah.
math that these kind of models can approach to. So I guess this basically is just showing the gap that we still don't know and don't understand about biology and medicine.
Yeah, and I think many of I mean most of the things that you said, or maybe all of it, it makes sense. And I hope that we are taught medicine in a way that is more similar to the reasoning that we require for math. But the nature of these two branches of the whole knowledge in the world is a bit different. I mean, math is not science, so it has its own way of coming up with new theories. And I mean, this is very different to a science like medicine that is basically uh, you can rely on findings empirically in the papers. For example, a question in medicine in this whole benchmark could be that what dosage of a specific drug should be given for a disease for a patient with a specific disease. And you cannot reason on that. This is something that should come out of some scientific work. And if the model has the chance that has come to the write papers mentioning the dosage of that drug, yeah, they will be able to answer that, hopefully in reference to that paper. You cannot reason on that from first principles, but in math, yeah, you can, and that is what makes these two sciences very two in these two branches very different.
So
The scientific nature, yeah,
Moin, let me disagree a little bit with you on that. I mean, I know that you just mentioned an example, but even on that example, you said, what dose of this medication is needed for a certain disease. I mean, there are many things that you could consider, and there is a lot of things that a pharmacist that we usually refer to for asking questions like that, they take into account, right? I don't think that they are very as complicated as these kind of very heavy math heavy kind of questions that these models go through, but we still need to take into account the pharmacodynamic of the medication. We still need to take into account the extent of liver disease or kidney disease or creatinine clearance level of a patient, and then think about how to basically adjust the exact amount of medication that this specific patient might need as a bolus dose or as a maintenance dose. So I think that again, this is just showing that we have not approached biology and medicine as a reasoning kind of science. We basically try to approach this as a kind of collection of facts to be memorized type of science, which is not the case, right? I guess that, again, I repeat, these models are not guilty. These are just approaching medicine in a way that we have taught them to do, and this is not going to be medicine. And I guess if we just let them on their own to go, and as we saw earlier with DeepSeek, to figure out how to approach medical problems, biology kind of problems, they will teach us how to approach medicine and biology in a more reasoning oriented way. So I think that this is not the nature of medicine or biology that doesn't need reasoning. It indeed needs much, much more reasoning than it needs memorization and facts. But unfortunately, our collection of historical science is not built like that so far. Moin, can you hear me? Oh my God, I think I lost him at the cross of my reasoning here. So let's see. I'm going to stop sharing my screen and pause.
think I'm back.
Yup, it seems that we
Yeah,
have you back. All
yeah,
right.
sorry for the technical difficulties. It's the internet here is very unstable, but I hope we can at least finish
Yeah.
our
No,
talk. Yeah,
I did my best. I did my best to pause the video whenever you had an interruption. So hopefully the full length recorded video is not going to have that much of a pause. Okay. So I'm going to share back my screen again where we were, and then
yeah,
we were talking about the humanities last exam, and we were talking about how. First of all, let's see. You are seeing my screen, right?
yes,
Okay, so I was telling you that I think that, so I'm not sure how much of that you heard, but basically
yeah. I followed that. Yeah,
okay, so perfect. So I'm just thinking that I summarized the last sentence. A lot of the reason that these biology and medicine kind of questions do not have that much of a reasoning on these benchmarks is because the models have been trained on question and answering in biology and medicine, which is aligned to our understanding of these fields, which is unfortunately mostly based on knowledge-based facts rather than knowledge-based reasoning. And, I think this is something that we probably can learn from large language models and AI in general as we go forward. And I think this gap between math and biology is not that real.
yeah. Okay, let me disagree a little bit. I think this is basically I think mostly it's based on the definition of reasoning that I'm thinking about. I'm seeing reasoning here, and in general, to be able to solve or come up with an answer to a question
Okay.
from the first principles of thinking, and just building on what you have found or what you have taught previously. And I think most of the questions in medicine, I'm not talking about physiology because lots of questions there could be answered uh, with just building upon what you know. But for example, the example that we talked about, yes, to answer that question, you need to know a lot about the patient, and it could be a very personalized answer. And yeah, knowing what things you need to know about that patient to answer that, uh, those are those are the parts that you are reasoning, and I think those tokens are probably being used in that case. But at the end of the day, you need to go and retrieve something from the database of all the papers and evidence that you have. You cannot come up with a number from first principles. But in math, you can answer a full question without relying on anything, and you can just build and build on the first principles of mathematics or in physics, and you're good to go. I think this is the different perspective I'm looking at it. I'm not saying that medicine doesn't require reasoning. It needs reasoning, but at last, you cannot go and come up with a number. You need to retrieve a database. And that is where the reasoning stops and memorizing the facts enters the field. I'm not sure how you agree with this one or disagree.
Oh, I kind of disagree still. I mean, and you and I can agree to disagree on it, but yeah, I get,
Definitely.
and I think that this entire content of biology and medicine could be formulated as mathematics, and this is something that we are not used to. We have not done. We have not learned like that. But every single medical query could actually be written in a mathematical kind of way. And I believe if we do so, then we can see it much clearer than how mathematical kind of reasoning could also be applied to biology and medicine. And the thing that you mentioned about retrieval, yeah, it also makes sense for mathematics as well because we have a lot of already proven kind of theories and things that you can just assume when you're answering a new question, and that's exactly true for biology and medicine. You can assume a lot of things that are already proven, or at least the evidence suggests like that, and then you can, try to come up with new conclusions on top of that ground. But so I don't want to escalate the discussion here, specifically as we are short in time. But again, so my one-liner on this is that every biological statement or question could be formulated in mathematics. And if we think of it like that, then this gap is not real.
Oh, okay. We should agree to disagree. Yeah.
Okay, all right. But anyways, thank you very much, Moin, for introducing this very interesting benchmark. I guess what we both agree on is that this is something to have an eye on, and
Definitely, yeah.
this is very cool. While you were gone, I also dug a little bit more into that benchmark that you shared earlier. So sorry, the website. There is an AI for that. Uh, there is just one thing that I honestly didn't like, and I want to bring that up about this website. Oh no, sorry, this one. Let me find that. Okay. So it seems that when you want, I'm not sure why it doesn't let me to open it, maybe because I had another page open somewhere. Here we go. So it seems that if you want to submit, one of your own AI solutions, if you just click on Submit Tool, which I guess there is the pathway that most of the people who work on AI should go through, they basically will charge you with some money. So, and it is not a cheap
Mm.
package at all. They ask for $300 to $350 for just showing
Oh,
your tool case here, which is a very unwanted turn down kind of feature. I really would love to see a platform like this that can let people to post their solutions for free. $300 for an independent developer is something that, they might not be very willing to pay. And then it's interesting,
yeah.
they have put an FAQ here, just, is there any way to submit my tool for free? And then they refer to a thread on X that you could go to and you could comment your tool for free. But when you come to this post, it has only 43 likes and 17 comments. So definitely this didn't work out. And I was kind of disappointed. I really liked the idea of the website and how they put together everything. And I think, yeah, I mean, for commercial kind of solutions and people who have investors, people who are willing to pay for their products, this is a very nice one. In case if you are just a developer who want to come up with some sort of, solution and share it with others, maybe this is not the best way to put together things. So
Yeah.
I just wanted to add to our discussion that we had earlier about this website that apparently it's not free for people to post their solutions to.
Yeah, thanks for bringing that up. And I think, yeah, that makes the tools introduced there very biased towards those who had the money to advertise it here. So, yeah, probably not the best kind of tool ever in the list. Best tool that the people who developed it had the money to advertise there.
Exactly, for commercial solutions. But still, I mean, still, I appreciate the efforts they put together. All right. So, Moin, do you have anything else to share? Otherwise, I can just quickly.
No, yeah. I think we have covered a lot, and
Okay.
that's enough probably for today.
All right. So I try to be very fast here. Let's see if I can find I just wanted to showcase a couple of things. One of them was this paper. Very quickly, I'm not going to deep dive into any of these, but just wanted to, as you and I were discussing before about a couple of papers like this that try to simulate the entire gaming industry using diffusion models and these kind of generative AI models. I just ran into another one which is named GameFactory. This is a new one for January 14th. And the idea is very simple. They are saying that, so I just trying to explain the entire idea as a whole, and then we can just go and to another paper. But the way they train their model is that they just pre-trained a model on some Minecraft kind of scenes, Minecraft-based kind of scenes, and they taught a diffusion model how to basically be sensitive to these keyword inputs like WASD, which are the main four keywords used for gaming, and basically they are used for navigation around in a gaming environment. So they trained a base model based on Minecraft derived data, and then they applied the same model to some of these video generative models. And what they are saying is that now we can use basically any video generative models to be promptable by this kind of keywords. So you can just walk into an environment that has been generated by a video generative models, and then they basically based on that, you can come up with new scenes. So the idea is very cool. And this is how they did that. They basically did it on a Minecraft game, right? And then they tried to generalize from that to open domain games. And so basically, they just recorded some videos out of Minecraft. That is how they did that, right? So somebody played the Minecraft. They basically just coded a script to play the Minecraft. They screen recorded that, trained the model on top of that, and now they can apply the model to some real videos. So these are synthetic videos. They are low res kind of videos because they needed to mimic the resolution of Minecraft. But still, they are just showing how pressing WA and SD is actually making work into these video generated environments. And the reason that I brought it up, and I think it's a very cool research, is that this is kind of bypassing the entire concept of game engines, right? Even an Unreal game engine. You basically are just trying to come up with a video to video kind of model or text to video kind of model. And based on that, a player can play in that. And this means that you can just basically come up with games on the fly. Very, very nice and cool paper and a very nice blog post with lots of interactive videos and demos to play with. So if you're interested, the name of that is GameFactory. And I guess we will see more and more of this kind of new generation of gaming videos. So that was one paper. Moin, if you want to share anything about this, go ahead. Otherwise, I can jump to the next one.
Yeah, definitely a very cool paper. Thanks for introducing, but I have nothing to add here.
All right, okay. So let's go to the next one. The next one, I'm trying to find it here. Hopefully, if not, I can just copy it from here. Let's see. Uh, Okay, here we go. Let me just copy the paste. I'm going to paste it here. So okay, this is a paper. We didn't talk that much about medical kind of domain sort of papers. This is a nice introduction to large language models and large multimodal models. If you are new to the field, this has been written for people in the medical domain. So this is something that you can go through with a little bit less complexity and less concern about understanding the technical keywords. You can basically just go through it, and it's a nice one. It talks about what LLMs are, what large multimodal models are. The thing that I really like about this paper is their illustrations. The figures are really, really well crafted. So from this history kind of figure to the one that they talk about tokenization, and I know that tokenization is a concept that many people from the medical domain have difficulty understanding or basically finding a relationship to because it's a difficult concept, but they nailed that. They basically just created very, very nice figures here. So I would say that if you're interested to learn about this kind of, LLM and LLM based workflows, give this paper a look. Again, this is large language models and large multimodal models in medical imaging, a primer for physicians. I unfortunately cannot see the citations sorry, the affiliations of, oh, here we go. Department of Radiology, University of Wisconsin-Madison. So this is from the University of Wisconsin, a very nice paper again, and also from Harvard. So the one of the at least corresponding authors is from Harvard. The other, both of them are from Harvard. So very nice ones. Nice paper from Harvard. I just wanted to highlight this as well. This was the second one. And then, Moin, again, a pause for you. Do you have anything to add about this?
I saw this paper when I was searching for the papers to introduce.
Okay.
I saw it, but I didn't go through the figures. Yeah, they really looks very well, and thanks for bringing that up.
Yeah.
I hope people could benefit from this, and it seems like a very well written paper.
Awesome. Yeah, it is. It certainly is. All right. And then my last item to go through two courses for people who are interested. The first one is a very nice course or a specialization of course on Coursera. Let me find the course very quickly here for you. Hopefully, oh, I think that, okay, so that was a tweet about that. So the specialization comes from deep learning.ai, which I believe, I mean, this is a team led by Andrew Ng, and they're nailing the entire education of AI and generative AI. And they have put together a specialization that I was personally waiting for. It's mathematics for machine learning and data science specialization. It's a very, very nice one. And if you go through that, you see that there are three courses here: linear algebra for machine learning and data science, calculus for machine learning and data science, and then finally probability and statistics for machine learning and data science. Exactly the three main topics that if people are willing to jump into AI, they need to know about. So if I open, for example, the linear algebra, as any other courses on Coursera, you can see the entire syllabus here, week one, talking about linear equations, linear transformations, determinants and eigenvectors, and all those things regarding vectors and matrices. And if I'm not wrong, so most of the courses on Coursera, you can audit as well without necessarily paying for the course. This is something that, if you're interested to do, I mean, definitely go ahead and pay for the course. You're going to receive a certificate. You are going to have access to the full content of the course. But most of the Coursera courses also provide you an option to just audit them. I am not seeing an audit option here, so now I'm a little bit in doubt whether or not they offer that. But at least the enrollment is kind of free. Oh yeah, here we go. So if you just click on this enroll for free, there is an option here, audit the course. And if you click on audit the course, then you're going to have access to some content of the course. And you need to commit to completing the course as well, which I know I hope I can hold my commitment. And then you are going to see the content. So this is a nice
Hi, and
course.
well,
Yeah, and this is the smiley, heart reassuring face of Andrew as well. So again, a very, very nice course for those of you who are interested in mathematics. And let me also quickly go through the next one because this also comes from the same team. Again, deep learning.ai. This is not on Coursera. This is on their own platform. And this is building towards computer use with Anthropic. And obviously, this is a course from the Anthropic team, and this is a nice course. I've already gone through half of that, not the entire length of the course. But if you just go through the course, so basically, this is a course in which they talk about how to work with the entire family of cloud models using Anthropic API. So they walk you through what the API is about, and as is the case with all courses from deeplearning.ai, you're going to have access to a nice video on one side and then another notebook environment on another side, so you can basically code while watching the video. This is a simple notebook environment. They walk you through how to basically call the API from Anthropic, how to put together a simple model. And this is a very nice course because throughout the course, they teach you some nuances of how to put together a deployment ready code, using this LLM API. So I guess this is something that even if you have already played with Cloud family of models or OpenAI family of models and you know how to call the APIs, again, it might be useful for you to take a look at because this guy here, who unfortunately I forgot the name, but he's very good in explaining and teaching and basically does the job very nicely. But he's from Anthropic and obviously talks about everything. And I believe in one of the final videos, he also talks about how to call the computer use, which is the tool Anthropic introduced a few weeks back. You can use it for, having an LLM control your mouse clicks and mouse scrolling, and basically what's the closest things that we have so far seen towards agentic AI, and it's very similar to what OpenAI announced yesterday regarding Operator. So again, a very nice course to have an eye on. Two very nice courses from Anthropic. One is on Coursera, the other is on their own website. And with that, I also bring my topics to an end. So, Moin, if you have anything to share about these two courses, go ahead. If not, feel free to add anything to the end of our discussion.
Thank you for introducing the courses. The last one looks very timely at this time that all of these companies are rolling out their features for computer use, and this will probably will be one of the most money generating features of these companies in the next few years, probably. No, I think I have covered what I wanted to cover, and yeah, like always, I learned a lot. Thank you. And
Thank
if you
you.
have anything to add, yeah,
No, thank you. Thank you very much. And thanks to everybody who watched us today. I really liked today's session. I have a couple of nice websites to go and explore a little bit, specifically that developer roadmaps. That is something that I'm going to dig into right now. And like always, learned a lot from you, Moin. Thanks for all the conversations, all the debates, and looking forward to our next meeting, hopefully not too far from now.
yeah, definitely. And yeah, I hope everyone enjoyed and have a good day.
Thank you. Have a good day too. Let me pause the recording.